Hello and welcome to Algebra 1, Solving Quadratic Equations and Describing Solutions. In this video, we will solve quadratic equations and determine the number of solutions by graphing, factoring, using the square root property and completing the square, and using the quadratic formula and knowing when to use these different methods. Here are some of the standards that we're going to cover in this video. These are from the Florida's Best Standards for Mathematics. In a previous video, we talked about how we can graph quadratic equations using standard form and vertex form. And we talked about the key features, but we didn't talk about the solutions. And that's what we're going to get into in this video. When we think about solutions, we're often thinking about what x and y value would satisfy the equation. So we learned that when we talked about linear equations. When I plug in x, I get a certain y, and that creates an xy coordinate that when I plug it in, my equation should be true. When it comes to quadratic equations, we're still looking for the x that is going to satisfy the equation. But these are a little bit tricky and they're a little bit different than what we learned when it came to linear equations. When we see a graph like this, where it doesn't touch the x-axis, there are no real solutions. These would have complex roots, and in Algebra 1, we're really just focused on the real number system. So the only thing you have to do for Algebra 1 is just notice that there are no real solutions. And we'll talk more about no solutions when we get into how to find the solutions. Here we can see that this particular parabola hits the x-axis at a single point. That's going to be called a double root, and we'll talk about why it's called a double root. But that's going to mean that it has one real solution. And then here we can see that it hits the x-axis twice, once here and once here, and that means we have two real solutions or two real roots. And we'll talk more about the discriminant or what these are when we get into the quadratic formula. For now, let's go ahead and talk about the 4 different ways that we can solve quadratic equations. We can graph, we can factor, we can complete the square, and we can use the quadratic formula. And different methods work for different things, and we're going to get into each one. First, starting off with graphing quadratic functions. Graphing, and we practiced this when we had standard form and vertex form, it's really great for being able to see how many solutions we have. So in this first graph here, we can see the parabola hits twice. It hits here and here. So right off the bat, we can see that there are 2 solutions. And when I look here, I can see that one of my solutions is going to be 3. And my other solution here is going to be 5. So in this case, we have 2 solutions where x can equal 3 and 5. In this one, we see that we have 1 solution, and that's going to be x equals 0. In this graph here down at the bottom, I can see that there are 2 solutions, one here and one here, but I can't exactly tell where they are. I know that this one is somewhere between -4 and -5, and this one is between -2 and -1, but I don't know the exact solution for this one because it's not hitting nicely in the corner of my boxes. So in this case, graphing tells me how many solutions, but it doesn't tell me what they are. For this one, I can see that there are no solutions for this one. But once again, it doesn't tell me my exact solutions. And so graphing is good when we want to know how many solutions we have. And sometimes it does tell us the solutions, but not all the time. Our second method is factoring, and we talked about when we were doing factoring that it can help us with solving quadratic equations, and now we're getting to that part. I went ahead and I factored this for us, and so I had my x factor here, and this is what I ended up with. Once you factor, you're going to take what's in the parentheses, just what's in the parentheses, and you're going to set both of those to 0. So I've got x minus 3 equals 0, and then I have x plus 1 equals 0. Then we're just going to get x by itself. So I have x equals 3, and x equals negative 1. And then I went ahead and graphed it over here just so you could see what this particular graph looks like. And we can see that it hits at negative 1 and 3. Same thing goes for this one. With this one, I'm going to take what's in the parentheses. What's out in front and the GCF that I pulled out in the front doesn't matter. We have x minus 4 equals 0, and then x minus 2 equals 0. I'm going to add 4 to both sides, and I get x equals positive 4, and x equals positive 2. And then once again, I have it graphed just so you can see what it looks like. And it hits nicely in those corners and we can see them pretty well. When we factored quadratic equations, we also ended up with some answers that looked like this. So with those other ones that were really simple, you were really just changing the sign of what you saw in the parentheses. But in this case, we would have 4x minus 5 equals 0, and then x minus 2 equals 0. So I know this one would be positive 2, but with this one I would have to do a little bit more work for that one. And that would give me 4x equals 5, and then to get x by itself we would divide by 4, and I get x is equal to 5 over 4, or 1.25. In Algebra 1, you probably won't see ones like this. They may ask you to factor something that looks like this, but they wouldn't necessarily give it to you in a problem asking you about factoring and solving for quadratic equations and actually finding the solution. We also had answers that also looked like this, where they both ended up being the same thing inside the parentheses. And in this case, we would have x plus 3 equals 0 and x plus 3 equals 0. They would both be the same. And in this case, they would both end up as x equals negative 3. So even though it's one solution, this is why it's called a double root. And it's because we see it 2 times. So that's where the double root comes in, because it's kind of confusing that double root would only be one solution, but it's because we end up having the same equation twice. So factoring seems like it would be a great method for solving quadratic equations, but we learned while we were doing factoring that not every quadratic equation is factorable. So it works great if they are factorable, but if they're not, you're kind of stuck and there's nowhere to go from there. And that brings us to our other two methods, completing the square and the quadratic formula. So completing the square, this one is a little bit more involved. If it's a process that you can remember, it's very, very useful. And it's especially great if you did really well on special products and recognizing those patterns. So let's go ahead and start with completing the square. So the first step is you want to make sure A is 1. And in this case, A is 1, so we're good to go to move on to the second step. The second step says move all constants to the other side. So I'm just going to go ahead and write out what we have here. And instead of putting y, I'm just going to put 0. And the second step says that we need to move all of the constants or numbers that don't have variables over to the other side. So I'm going to move this over to the right. And I end up with x squared minus 8x equals negative 13. Step number 3 says take half of b, and we can see that b is -8. So I have -8 divided by 2, and I get -4. And then it asks me to square it. So I'm going to square -4, and I get 16. And then it says add it to both sides. So now I have plus 16 on both sides. These aren't like terms, so I'm just going to go ahead and write them all out. And -13 plus 16 is +3. From here, we're going to rewrite the perfect square on the left. This is where those special products come in. And there's a quick way of kind of looking at our pattern. So I have -4 here. So to rewrite this as a square, I'm going to do x, then -4 squared equals 3. And we learned while we were doing our special product patterns that this would turn out to be x squared. So if I FOILed this out, just quickly writing it up here at the top so you can see it kind of expanded, this would be x squared. Then we have -4x, -4x, and then -4 times -4, and we end up with this. So this is kind of your shortcut way of doing this. Step 5 says take the square root of both sides. And a square and a square root is going to cancel, so I end up with x minus 4 equals the square root of 3. Now, I don't want you to do anything with the square root of 3 yet. When we've been taking square roots, we've always just been assuming that the number is positive, but we know that it could be a number times itself being positive or multiplying itself when it's negative, and it still would give us that +3. So let's go ahead and get x by itself. So we have +4 and +4. So now I have x equals 4 plus or minus the square root of 3. That means I have two different possibilities for my numbers. I can have 4 plus the square root of 3, and I can have 4 minus the square root of 3. And that makes sense because when I look at my axis of symmetry is at 4. And then what it's asking us to do is subtract the square root of 3, and we get this root. And then we're going to add the square root of 3 and get the other root. So now I'm just going to plug this into my calculator. So I'm going to clear out my calculator, and I have 4 plus 3 square root, and then make sure you hit that equals button or it's only going to show you what the square root of 3 is. And I get 5.732. So we're just going to round that to 5.7. And remember, these are rounded numbers because this is an irrational number. Then I have 4 minus 3 square root equals, and I get 2.3 here. And so if they were asking for exact answers, this is what I would have given them. But if they're asking me to round, then these would be fine. But notice that if I was just doing graphing, I wouldn't be able to tell what these are. I wouldn't be able to guess that decimal value or even a rounded version of that, that value. Let's try another example. So our first step was to make sure that a is equal to 1. And we notice that a is equal to -2 here. So all you're going to do is just divide everything by -2. And I end up with x squared plus 8x and then plus 15. And then instead of equals y, I'm just going to put equals 0. Then I'm going to move all of my constants to the other side. So I'm going to do minus 15. I get x squared plus 8x equals negative 15. And then we're going to do step 3. So I have B, which is 8. So we've got a positive 8 here. Divided by 2 equals 4. Then I'm going to square that number and add it to both sides. So now I have plus 16 on both sides. This gives me x squared plus 8x plus 16 equals positive 1. And then I told you our shortcut way for this particular process is going to be x. And then we're going to take that number that we squared, which is a positive 4, and put a squared there on the outside. From here, we're going to take the square root of both sides, and I get x plus 4 equals the square root of 1. And then from here, I'm going to get x by itself, and I get x equals negative 4 plus or minus the square root of 1. And we know that the square root of 1 is just 1, so that's going to be negative 4 plus or minus 1. So negative 4 plus 1 gives us negative 3. And then negative 4 minus 1 gives us negative 5. And then when you go to plug this in to your computer, sometimes they ask you to just write out your solutions with a comma in between. I usually like to put mine in order from least to greatest, so I'll probably put negative 5 and then negative 3. Sometimes they'll ask you to put it in set notation. It just kind of depends on what test you're taking and who made your test. And then here, when we look at it graphed, we can see that our solutions are at negative 5 and negative 3. And we can also see that completing the square is also a good way to find our axis of symmetry, which is x equals negative 4, as this would be our axis of symmetry. Let's go ahead and try a few more examples. If you feel like you have completing the square down, you are free to skip ahead and start looking at the quadratic formula, but there are a couple of these examples that you probably want to see, especially number 6. So go ahead and write these down, try them out, and then check your work. All right, starting with our first one, I'm just going to copy it down. I can see that A is 1, and so that one is good to go. I'm going to go ahead and move all of my constants over to one side. I have x squared plus 6x equals 16. From here, I want to take my B value, which is positive 6, divide it by 2, and I get 3. I'm going to square that number, and I get 9. I'm going to add that to both sides. X squared plus 6x plus 9 equals 16 plus 9, which is 25. From here, I'm going to do my shortcut. I have a positive 3 here. That means when I write this as a square, we have x plus 3 squared equals 25. I'm going to take the square root of both sides. X plus 3 equals the square root of 25. Isolate x. X equals negative 3 plus or minus the square root of 25. I know the square root of 25 can either be 5 or negative 5, which means I have negative 3 plus or minus 5. Writing out my first answer, I have negative 3 plus 5, and that gives me positive 2. Negative 3 minus 5 gives me negative 8. And I'm going to go ahead and write these two in order. And that would be my answer for number 1. On to number 2, we have x squared minus 2x minus 14 equals 0. First, I want to make sure a is 1, and it is. I'm going to move over my constants. I get x squared minus 2x equals 14. From here, I'm going to take my b value, which is negative 2. Divide that by 2, I get negative 1. I'm going to square that. That gives me positive 1. And I'm going to add that to both sides. X squared minus 2x plus 1 equals 15. I want to take my shortcut and think about what I squared. That gives me x minus 1 squared equals 15. Take the square root of both sides. X minus 1 equals the square root of 15. Add 1 to both sides, and I get x equals positive 1 plus or minus the square root of 15. I know that the square root of 15 can't be simplified, and so this would be my exact answer. Or you could write this as 1 plus the square root of 15, and then 1 minus the square root of 15. Just kind of depends on if you're taking a multiple choice test. You might see something like this where they give both of these. Or they might ask you to round your answer. In this case, we're going to use our calculator. So I'm going to go ahead and clear it out. 1 plus 15 square root equals, and I get 4.87 or 4.9. For my second one, 1 minus 15 square root equals negative 2.9. And then I can write this out looking something like this. Depends on what test you're taking. For number 3, we have x squared minus 8x minus 1 equals 8. A is 1, so I can continue. I want to move all of my constants over to one side. X squared minus 8x equals 9. From here, take my b value, negative 8. Divide it by 2. I get negative 4. We're going to square that. That gives me positive 16. Add that to both sides. X squared minus 8x plus 16 equals 25. I'm going to use my shortcut to write it as a square. X minus 4 squared equals 25. Take the square root of both sides. X minus 4 equals the square root of 25. Add 4 to both sides. X equals 4 plus or minus the square root of 25. And I know the square root of 25 can simplify to just 5. So I know that that is going to be 4 plus or minus 5. And so you could write that as your answer. We have 4 plus 5, which gives us 9. 4 minus 5 gives us negative 1. So our answer could be negative 1 or 9. For number 4, we have x squared minus 10x equals 23. This one is already set up and ready for us to go ahead and begin. 1 is A, and our constant is already moved over to the other side. So we can go ahead and take our B value, which is -10, divided by 2, and we get -5. We're going to square that number, and that gives us positive 25. So I'm going to add 25 to both sides. X squared minus 10x plus 25 equals 48. From here, I'm going to write it as a square, and I'm going to use my shortcut. I want to take the square root of both sides. X minus 5 equals the square root of 48. Add 5 to both sides. X equals 5 plus or minus the square root of 48. In this case, you're going to want to simplify your radical, so that might be something that you need to go back and look at and review, especially before taking your EOC. I like to use prime factorization, especially if you have a hard time with knowing your perfect squares and what perfect squares go into a number. You can always do prime factorization. So I'm just going to put that over here on the right. So I went ahead and broke down 48 into its prime factorization. And then we know that we're going to move a 2. We're going to move out another 2. That's going to turn into 2 times 2 times the square root of 3, or 4 times the square root of 3. So when I go to write my answer, it's going to be x equals 5 plus or minus 4 times the square root of 3. So if you're taking your EOC, they might ask you to do something like this, especially because that's something that we learned in Algebra 1. And then from here, I have 5 plus 4 times the square root of 3, and then 5 minus 4 times the square root of 3. These would be my exact answers, but they might ask you to put it into your calculator. And in this case, we would have 5 plus 4 times 3 square root equals, and that gives us 11.9. And then we're going to do the same thing, but with minus. 5 minus 4 times 3 square root equals, and I get negative 1.9. And so negative 1.9 and 11.9 would be my answers if they asked it, if they wanted me to round. All right, now looking at number 5, I have 2x squared minus 2x plus 7 equals 5. Right off the bat, I can see that A is not 1, so I need to divide everything by that number out in front so that can be 1. So I'm going to divide everything by a positive 2. And I get x squared minus x plus 7 over 2 equals 5 over 2. We're going to subtract 7 over 2 from both sides. And I get x squared minus x equals, and if you need to put this in your calculator, then put it in your calculator. We have parentheses 5 divided by 2, close parentheses, minus parentheses 7 divided by 2, close parentheses equals, and I get negative 1 here. So don't get discouraged, especially if you see some decimals here. Completing the square works really well when A, B, and C are integers, but when A is starting out with a fraction, it can be a little bit more tricky. It's still doable, but you might want to do quadratic formula instead. All right, so now from here we've got this. I'm going to take my b value, which is -1. -1 divided by 2 is -0.5 squared. And that's going to give me positive 0.25. I'm going to add 0.25 to both sides. X squared minus x plus 0.25 equals, and then -1 plus a quarter is going to be -0.75 here. And then from here, we've got, and we're just going to treat this the same way that we've been treating it. So you're still going to do your shortcut. You're going to treat this just like any other number, so don't worry. And we get x minus 0.5 squared equals -0.75. And then here we're going to take the square root of both sides. From here, I get x minus 0.5 equals the square root of -0.75. Now just listen, when we have the square root of a negative number, there is no number that can multiply by itself to give us a negative. When we have something like -3 times -3, it turns out to be a positive. When we see this, that means it's automatically going to be a complex number involving imaginary numbers. And this is something that we're going to handle in Algebra 2. So at this point, for Algebra 1, you're going to stop whenever you see a negative under your square root. And this is going to be no solution. That doesn't mean that every time you see decimals that it would be a no solution. It could be, but it might actually work out because we still treat it the same way. But in this case, it ended up being negative. And so that's why this particular equation is no solution. Not because that it had fractions or decimals, but because we have a negative underneath that radical. All right, last one. We have 3x squared plus 12x plus 81 equals 0. I can see that I don't have 1 in the front, so I'm going to divide everything by 3. And I get x squared plus 4x. And then if you are struggling with doing this in your head, go ahead and put it in your calculator, but this is going to give us 27 and 0. From here, I want to move over my constants. I get x squared minus 4x equals -27. From here, I'm going to take my b value. -4 divided by 2 gives us -2. Squared gives us 4 again. So I'm going to add 4 to both sides. X squared minus 4x plus 4 equals -23. Then from here, I'm going to do my shortcut. I've got -2 over here, and that's going to help me with writing this as a square. And then from here, I'm going to take the square root of both sides. And then notice from here again, we've got a negative underneath our radical. So this one is going to be no solution. All right, and that sums it up. Very easy process. It just a lot of steps to kind of remember, but if you can remember it, it's a good way to solve quadratic equations, and it can tell you whether it has two solutions or no solutions very easily. Now let's jump into our last method, which is using the quadratic formula. I really like using the quadratic formula simply because it's one formula. You don't have to do any factoring or remember a whole bunch of steps. And they also give this to you on your reference sheet. So what you see in the yellow box, they actually give on your EOC reference sheet. And a lot of times it's on the reference sheet for standardized testing. So it's a lot less to remember than completing the square, and it's a lot less involved. One thing you may want to add to your reference sheet though are little parentheses, especially around your B value. And that's because with our scientific calculator, it's pretty intuitive about making sure that it's using the correct order of operations when we square things. But this is where a lot of people get into trouble when they switch over to graphing calculators that aren't as intuitive for that specific skill or input for the calculator. So you might want to add some parentheses in there. All right, so let's go ahead and get started. So the first thing you notice with this formula is we have B, A, and C. So this kind of goes back into what we were doing with factoring and when we were graphing quadratics, where we had to identify A, B, and C first. With these, you do not have to do any factoring first. You can plug them straight in as they are. So A is going to be -2. B is going to be +12, and then C is going to be -16. Don't forget those signs in the front. All right, now from here, we're going to go ahead and put this into our formula. So I'm not going to rewrite it. When I'm taking a test, I normally write out my formula and then put my stuff down. It just makes it a lot easier for error analysis if I need to go back and look at something. But in this case, we're just going to use what's already on our paper. So we've got negative B, which is 12, plus or minus the square root of B, which is 12, squared, minus 4 times our A value, which is -2, times our C value, which is -16. And then this is all going to be over 2 times our A value, which is -2. I like to write, and we've talked about this before, that when you are dividing by something and you have a plus or minus somewhere, that you can write it underneath both sets of things. And so let me show you what that looks like. So now from here, and this helps me, when I'm using graphing calculators, I would type out this entire thing into my calculator because I love using parentheses. But with our scientific calculator, it would be way too easy to make a mistake. So let's go ahead and narrow some of this down first. So we've got -12, and then we're going to put that over what we had on the bottom. 2 times -2 gives us -4. Plus or minus, and then I'm going to type this entire thing into my calculator. So let me bring up my calculator. I'm going to clear it out. I have open parentheses 12 close parentheses squared -4 times 2, make it negative, times 16, make it negative, equals, and I get +16 here. And then that is also going to be over this number. So 2 times -2 is -4. Do not put that -4 underneath your radical. It's by itself in the denominator. That's really important. All right, now from here, I have -12 divided by -4, and that gives me +3, plus or minus, and then my square root of 16 is 4, divided by -4 gives me -1. And so this would be my answer, 3 plus or minus -1. So from here, I've got 3 plus -1, which gives me 2, and then 3 minus -1, which gives me 4. And then if you look over here on our graph where I graphed it, we have 2 and 4 there. All right, completing the square could have been a little difficult just because it doesn't look like the other things that we've been doing with completing the square. So for this one is super duper easy. We have A, B, and C. A is 3 and then B is 0 and so is C. So this becomes super fast in putting it in the quadratic formula. I have negative B, which is 0, plus or minus, and then I have 0 squared minus 4 times A, which is 3, times 0. So that whole thing's going to be 0. And then I'm dividing this by 2 times A value, which is 3. So now I've got 0 over 6 plus or minus the square root of 0 minus 0, which gives me the square root of 0, over 6. And this ends up being 0 plus or minus 0, which I guess we can guess to say that it's going to be 0. And so with this one, it's super duper easy with the quadratic formula. We could have seen from a mile away that that would be 0. And from here, now that we're looking at the graph, we can see that we only have one solution here, and that's going to be 0. All right, trying out another one. We have A, B, and C. 2, 16, and 36. And the quadratic formula, I also like it because even if you have really big numbers and maybe you don't feel like factoring, just to find out that it's not factorable, or having to deal with completing the square, your quadratic formula is always going to work. So the quadratic formula, you definitely need to know how to put it in your calculator and make sure that you're using your reference sheet, but this is the go-to unless the question specifically asks for you to factor or complete the square or graph. Quadratic formula is the best way to go. All right, here we've got negative and then our B value, which is 16, plus or minus the square root of B, which is 16, squared minus 4, times our A value, which is 2, times our C value, which is 36, all over 2 times our A value, which is 2. So now I'm going to come underneath here, and we've got negative 16 over 2 times 2, which is 4, plus or minus, and then I'm going to put this whole thing in my calculator. So let's go ahead and clear it out. I've got parentheses 16, close parentheses, squared, minus 4 times 2 times 36 equals, and I get negative 32 over 4. And then notice that I've got that negative underneath my square root, and so this is automatically going to be no solutions. And here we've got negative 16 divided by 4 gives us negative 4. And I want you to take a quick notice as to what our quadratic formula is saying. Our quadratic formula is saying negative B over 2A. And if you remember from when we were graphing our quadratic equations, we used negative B over 2A as our axis of symmetry. So negative 4 is our axis of symmetry. So just like with completing that square, that number before the plus or minus is going to be your axis of symmetry. So your quadratic formula kind of reminds you that your axis of symmetry is equal to x equals negative b over 2a. And then at the beginning of this video, we talked about the discriminant. And this piece here, b squared minus 4ac, what's underneath your radical is called your discriminant. So let's go back to the beginning real quick. When we talked about looking at the number of solutions, I said that if b squared minus 4ac was negative, it ended up having no real solutions. And that's because we couldn't take the square root of that number because it was negative. And it told us that we were going to have to be dealing with some imaginary numbers and complex solutions. Then when we have b is equal to 0, you're not going to the left or to the right of that number. So that means if you are adding 0 to both sides, or if b squared minus 4ac is 0, you're going to have one solution. And then if it was that positive number, we knew that it was going to give us two different solutions there. So now we're going to do one last problem, and then we're going to close out this video. We have x equals, and then we need to identify our a, b, and c. A is going to be 1, b is going to be -8, and c is going to be 13. So I've got negative b, which is -8, plus or minus the square root of -8 squared. This is why the parentheses are so important, especially when you're using your graphing calculator. Minus 4 times our a value, 1, times our c value, 13, all over 2 times our a value, which is 1. From here, a -8 is going to be +8 over 2 times 1, which is 2, plus or minus, and then let's go ahead and put all that into our calculator. So with this one, I have open parentheses, 8 negative close parentheses squared minus 4 times 1 times 13 equals 12. And then that's going to be over 2 times 1, which is 2. From here, I want to go ahead and simplify the square root of 12. And so I can break it down into its prime factorization. If you know how to do this with your perfect squares, then by all means do that. But if you struggle kind of remembering what your perfect squares are, or if you're dealing with larger numbers, you might want to use prime factorization. All right? It just makes it a little bit faster, especially when you can't look up factors in a graphing calculator. All right, here we go. So we've got 2 out to the side, and then we have our square root of 3. So 4 plus or minus 2 times the square root of 3, which is taking place of this square root of 12, and then over that 2. Then you're going to treat this just like a fraction. 2 divided by 2 simplifies out to 1, and that turns into 4 plus or minus 1 times the square root of 3. And then from here, I have 4 plus the square root of 3, 4 minus the square root of 3, and then I can put these in my calculator. So I've got 4 plus 3 square root equals, and I get 5.7. And based on my graph over here, that looks like it makes sense. It's past the 5.5 mark. And then we have 4 minus 3 square root equals, and I get 2.3-ish. And that makes sense because it's in between that 2 and 2.5. And so that's how you use your quadratic formula, and that is how you solve quadratic equations using graphing, factoring, the completing the square method, and your quadratic formula method.